Grounding water pipes is a safety measure intended to prevent electrical current from flowing through metal pipes, protecting individuals from potential shocks. While theoretically possible, the scenario of someone getting shocked in the shower due to improperly grounded water pipes is exceptionally rare. For a shock to occur, there must be a fault current flowing through the water pipes, and a person must simultaneously contact the grounded pipe and another electrical source, such as a malfunctioning appliance or a faulty power outlet. Electrical codes and regulations are specifically designed to prevent such occurrences by mandating proper grounding and bonding of electrical systems and appliances. Firstly, the fault current is often low. In most cases, fault currents that could potentially cause a shock in the shower are relatively low in amperage and unlikely to cause serious injury. Secondly, ground fault circuit interrupters provide protection. Many homes are equipped with ground fault circuit interrupters, known as GFCIs, which are designed to trip and cut off power if they detect a fault current flowing to ground. GFCIs are commonly installed in bathrooms and other areas where there is an increased risk of electrical shock due to the presence of water. Thirdly, isolation valves play a role. Many water heaters and plumbing fixtures incorporate isolation valves, which can be closed to isolate the water pipes from the electrical system. This isolation can effectively prevent fault current from flowing through the pipes. To elaborate on the concept of grounding, it's essential to understand its purpose within an electrical system. Grounding provides a low resistance path for fault current to return to the source, typically the electrical panel. This path allows the circuit breaker or fuse to trip, disconnecting the power and preventing a sustained shock hazard. Without proper grounding, a fault current could flow through unintended paths such as water pipes, increasing the risk of electrical shock. Bonding, closely related to grounding, involves connecting all metallic parts of the electrical system, including water pipes, to create an electrically continuous path. This ensures that all metallic components are at the same electrical potential, minimizing the voltage difference between them. If a fault occurs, the current will flow safely through the bonded components, tripping the circuit breaker and preventing a shock. Electrical codes, such as the National Electrical Code, often abbreviated as NEC, provide detailed requirements for grounding and bonding electrical systems. These codes specify the size and type of grounding conductors, the methods for connecting grounding electrodes, and the requirements for bonding metallic components. Compliance with these codes is crucial for ensuring the safety of electrical installations. Regarding GFCIs, these devices constantly monitor the current flowing in the hot and neutral conductors of a circuit. If there is a difference of even a few milliamperes between these currents, it indicates that some current is flowing through an unintended path, such as a person's body. The GFCI quickly trips, typically within a fraction of a second, cutting off the power and preventing a serious shock. GFCIs are highly effective in preventing electrical shocks in wet environments, such as bathrooms and kitchens. They are required by electrical codes in these areas and are a valuable safety device. The risk of electrical shock from water pipes is also minimized by the properties of water itself. While pure water is a poor conductor of electricity, tap water contains impurities and minerals that make it more conductive. However, the resistance of the water in a plumbing system is still relatively high, which limits the amount of current that can flow through it. Additionally, the human body has a certain amount of resistance to electrical current. The amount of current required to cause a shock depends on factors such as the voltage, the path of the current through the body, and the duration of the exposure. Low voltage shocks, such as those from static electricity, are generally harmless, while high voltage shocks can be life-threatening. The severity of an electrical shock also depends on the individual's health and sensitivity to electricity. Some people are more susceptible to electrical shock than others. The presence of moisture, such as in a shower, significantly reduces the body's resistance to electrical current, increasing the risk of shock. That's why GFCIs are so important in these environments. In the specific scenario of a shower, the water spray can create a conductive path between the person and the grounded water pipes. If there is a fault current flowing through the pipes, the person could receive a shock. However, as mentioned earlier, this scenario is very rare due to the safety measures in place, such as grounding, bonding, and GFCI protection. To further minimize the risk of electrical shock in the shower, it is important to ensure that all electrical appliances and fixtures in the bathroom are properly grounded and in good working order. Avoid using electrical appliances near water, and never touch electrical devices with wet hands. If you notice any signs of electrical problems, such as flickering lights or sparky outlets, have them repaired by a qualified electrician immediately. Regular inspections of your home's electrical system can help identify potential hazards and prevent electrical shocks. These inspections should include checking the condition of wiring, outlets, and circuit breakers, as well as testing the operation of GFCIs. If you have any concerns about the safety of your home's electrical system, consult with a licensed electrician. They can perform a thorough inspection and provide recommendations for improving safety. While the risk of electrical shock from water pipes is low, it is still important to be aware of the potential hazards and take steps to minimize them. By following electrical codes and safety measures, you can create a safe environment for yourself and your family. In addition to the measures already discussed, there are other factors that can contribute to electrical safety in the home. Surge protectors can help protect electronic devices from voltage spikes, which can damage sensitive equipment. Arc full circuit interrupters, called GFCIs, can detect dangerous arcing conditions in wiring and trip the circuit breaker, preventing fires. Tamper-resistant receptacles, known as TRR, have shutters that prevent children from inserting objects into the outlets. These devices can help prevent electrical shocks and injuries. When working with electricity, it is always important to follow safety precautions. Turn off the power at the circuit breaker before working on any electrical circuits. Use insulated tools and wear rubber gloves and shoes. Never work on electrical circuits when you are wet or standing in water. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, and it is important to take it seriously. By following these safety guidelines, you can protect yourself and your family from electrical shocks and other hazards. In summary, while the theoretical possibility of receiving an electrical shock in the shower due to improperly grounded water pipes exists, the actual likelihood of this occurring is extremely low. This is due to a combination of factors, including low fault current, GFCI protection, isolation valves, and adherence to electrical codes and safety regulations. Nonetheless, it is crucial to maintain awareness of potential electrical hazards and to take proactive steps to minimize risks. Ensuring proper grounding and bonding of electrical systems and appliances, regularly testing GFCIs, and promptly addressing any electrical issues can significantly enhance safety in the home. Always prioritize electrical safety and seek assistance from qualified professionals when necessary. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations covering aspects such as wiring methods, overcurrent protection, grounding, and bonding. Adherence to the NEC is essential for ensuring the safety and reliability of electrical systems. The NEC is updated regularly to reflect advancements in technology and evolving safety standards. Local jurisdictions often adopt and enforce the NEC, ensuring that electrical installations comply with the latest requirements. Electrical inspections are conducted to verify compliance with the NEC and other applicable codes. These inspections help to identify potential hazards and ensure that electrical systems are installed and maintained safely. Electrical safety is a shared responsibility involving homeowners, electricians, and regulatory authorities. By working together, we can create safer homes and communities. The principles of grounding and bonding are fundamental to electrical safety. Grounding provides a path for fault current to return to the source, while bonding ensures that all metallic components are at the same electrical potential. These measures help to prevent electrical shocks and minimize the risk of fire. Electrical systems are designed to operate within specific voltage and current ranges. Overloading circuits can cause wires to overheat and potentially start a fire. It is important to use the correct size circuit breakers and fuses to protect electrical circuits from overcurrents. Extension cords should be used sparingly and should be properly sized for the load they are carrying. Damaged extension cords can pose a serious electrical hazard. It is important to inspect extension cords regularly and replace them if they are damaged. Electrical appliances should be used in accordance with the manufacturer's instructions. Misusing electrical appliances can lead to electrical shocks and other hazards. Water and electricity do not mix. Never use electrical appliances near water or touch electrical devices with wet hands. If an electrical appliance falls into water, do not touch it. Turn off the power at the circuit breaker and then remove the appliance from the water. Electrical safety is an ongoing process. It is important to stay informed about electrical hazards and take steps to protect yourself and your family. By following these safety guidelines, you can create a safer home environment. Let's now discuss some additional aspects of electrical safety related to specific appliances and situations. For example, portable generators can be a valuable source of power during outages, but they can also pose electrical hazards if not used properly. Never operate a generator indoors or in a partially enclosed space, as this can lead to carbon monoxide poisoning. Connect appliances directly to the generator or use a heavy-duty extension cord. Never connect a generator directly to your home's electrical system without a transfer switch, as this can backfeed electricity into the power grid and endanger utility workers. When using power tools, always wear appropriate safety gear, including eye protection and gloves. Inspect power tools regularly for damage and never use them if they are defective. Be aware of overhead power lines when using ladders or other equipment. Maintain a safe distance from power lines to avoid electrical shock. If you are working on a construction site, follow all electrical safety regulations and guidelines. Construction sites can be particularly hazardous due to the presence of exposed wiring and other electrical hazards. In agricultural settings, electrical safety is also critical. Be aware of overhead power lines when operating farm equipment. Ensure that all electrical equipment is properly grounded and maintained. Avoid using electrical appliances near water or livestock. In marine environments, electrical safety is paramount. Boats and docks should be equipped with ground fault protection to prevent electrical shocks. Never swim near docks or boats that have electrical connections. Electrical storms can pose a significant electrical hazard. During a thunderstorm, avoid using electrical appliances and stay away from windows and doors. If you're outdoors, seek shelter in a building or a car. Trees can conduct electricity, so avoid standing under trees during a thunderstorm. Lightning rods can help protect buildings from lightning strikes by providing a path for the electricity to flow to the ground. If you are planning to install a lightning rod system, consult with a qualified contractor. Static electricity can cause minor shocks, but it is generally not dangerous. However, static electricity can ignite flammable materials, so it is important to take precautions when working with these materials. In healthcare facilities, electrical safety is of utmost importance. Medical equipment must be properly grounded and maintained to prevent electrical shocks to patients and staff. Healthcare workers should be trained in electrical safety procedures. In industrial settings, electrical safety is a critical component of workplace safety. Employees should be trained in electrical safety procedures and provided with appropriate personal protective equipment. Electrical equipment should be regularly inspected and maintained to prevent electrical hazards. The National Fire Protection Association, abbreviated as NFPA, develops and publishes codes and standards related to fire and electrical safety. These codes and standards are widely used in the United States and other countries. The Occupational Safety and Health Administration, called OSHA, enforces workplace safety regulations, including electrical safety regulations. Employers are required to provide a safe working environment for their employees. Electrical safety is a shared responsibility that requires the cooperation of individuals, businesses, and government agencies. By working together, we can create a safer world for everyone.